Hello and welcome to T3 Day 27 of Honors Precalculus. Today we're going to talk about limits. The basic idea here is we're going to have an operation that we're going to do over and over and over again, and we're going to see how close we get to something. Do we get close to something or do we not get close to something? Some of these limits are going to be pretty straightforward and some of them are going to be pretty interesting and take us on some fun journeys. The expression, this expression right here, I'll try to get to a highlighter so I don't actually X it out here. This expression right here reads, as the limit as x approaches c of f of x is L. So as x goes to c, f of x gets close to L. So as x goes to c, the output gets to L. So one way to evaluate limits is with a table. So for example, this one, what happens as x goes to 2 of x squared? What we do right here to set this up is we're not going to plug in 2. We're going to say, like, what happens as x goes to 2? As x gets closer to 2 from the left and from the right. So what are some numbers to the right and to the left of 2? Well, 2.001 is really close. We're also going to do 2.01 and 2.1. And then to the left, what do you have? You have 1.999, and then you'd have 1.99, and then you'd have 1.9. And what you do is you take these values, 1.9, 1.99, and you plug them in to the function there. And what do you get out? You get these values. Now, what does it look like? Not what does it look like these are getting close to as these go in? What really looks like they're going to 4. So what we can say is we think this is going to 4. This is a visual way of doing it with a table. Now you're right, you could plug in 2 just to get 4, but we want to see what happens as you get infinitely close from the left and the right, because you're not always going to be able to plug in values here. And again, this was x squared. So down here, you'd have 2x plus 3, and we're going to 0. That's what we're getting close to right there in the middle. So what, from the right and from the left, what numbers you're plugging in as you get close there are going to be very similar, 0, 0, 1, 0.001, and then you get 0.01, you get 0.1, and then to the left here, you get negative 0.01, like this, and then you get negative 0.1, and you plug all of those values into this, and what do you get out? You get a train of numbers like this. So what does it look like it's getting close to right here? Well, it looks like you're getting really close to 3. So we're going to say the limit here gets infinitely close to 3. Now you might say again, why don't we just plug the 0 in? Well, you can't always plug it in. And the table values, using a table for these is kind of like using the quadratic formula. It's always going to give us an idea of what the answer is. Now in this case, when we plug this one as 1 over x, again we have 0 there, and we plug in the same x values like this, and when we plug these values in, you end up with negative 10 on this side, and then negative 100, and then negative 1,000, and then you end up with 1,000, 110. Well, you'll notice here, are these close together? They are not. What we say here is it does not exist. When you graph this, you'd see it too. We say that this does not exist. A visual way to see that is when you graph that, you end up with this kind of graph here. What happens as you go to 0? Well, it goes infinitely up here and it goes infinitely down there, so we say it does not exist. What about on this one right here? You can't plug in 3, and it's really important that when you do this out, if you plug this in, so this is the function right here, we're putting it in right here, and you plug in it and you make a table of values here where 3 is in the middle. Again, the numbers to the right are 3.001, 3.01, and 3.1, and then to the left, you get those. When you plug in those values into your calculator, you plug that value in right here, you plug this in, what do you get out? You get these values. And what does this look like? What really looks like these are getting close to 6. They're getting close to 6. And you might notice that you might have another way of doing this, but what's really cool about this is this table gives you a very good idea of what the answer is. It's not quite a proof. You might notice that you can factor the top into x plus 3 times x minus 3. And then what cancels here? Oh, the x minus 3's cancel, leaving me with x plus 3. What's 3 plus 3? 6. So that's one way to think about it, and we're going to get to that algebraic method. On this one right here, there is no way to super simplify it right here, but if you put this down here, and you were going to 0 here, so 0's in the center, you do the same first row. So there's your first row. When you plug these numbers in, you end up with 1.9, 1.99, 1.999, and then on the other side you get 2.001. It's not always perfectly symmetric, but it can be. You get 2.1. What does it look like these are getting close to? It looks like they're getting close to 2. And this is the way in which tables can be really helpful. There's nothing much we can do to this to simplify it algebraically, so this table value is a way to get the limit. We say the limit here would be 2. It's pretty cool. Another way to take limits is from the left and from the right and by being given a graph. So what this says right here, what's the limit as you go from x goes to 0 from the left? Here's x equals 0 right here. That's the y-axis. If you're traveling along, if you're a bug traveling along here and your x value is approaching 0 from the left, what are you getting infinitely close to for an output? You're getting infinitely close to 0 from the output. Like remember, you're a bug, you're walking along here, your x value is getting infinitely close to 0 from the left. What are you going to see? You're going to see this point and this point only here. And what's the height of that point? It is 0. Now what about approaching 0 from the right? If you're approaching 0 from the right, you're coming down here, the bug is approaching 0 from the right, you're approaching 0 from the right. What do you get infinitely close to? What output level do you get infinitely close to here? You get infinitely close to an output level of 2 right there, to 2. Now, what about when it just says limit as x goes to 0? That means from both sides. Here's the thing, from the left it's 0, from the right it's 2. There are two different values. What we say is it does not exist. If you approach different values from the left and right, we say it does not exist. So let's do another one. What about this one right here? What happens as you approach 2 from the left here? 2 from the left. If you're a bug here, 2 from the left, you're walking along here, 2 from the left, you're going to go 2, the x value is 2, remember. Oh, it's going to be this right here. Looks like it's 4. What about 2 from the right? 2 from the right is also going to be 4. But what is the limit as x goes to 2? Well, it's the same thing on both sides. It's actually going to be 4, because from both sides it's 4, so the limit is said to be 4. But here's a good, cool question for you. What is f of 2? If you evaluate this function at 2, what is it? If you go to 2 and you go straight up, it actually is 2. So what the function is at that point can sometimes be totally different than what the limit is. What does the bug coming from the left see? It sees 4. From the right, what does it see? A bug walking? Oh, it's 4. That's why these are 4 and this is 4. But if you go to 2 and go up, it's at 2 here. That's why this is 2. So these limits are pretty cool because you don't need a table and you don't need a graph. You can just plug in on these. The first thing you always check is for evaluating limit, can you evaluate it? This is just going to be 2 times 2 plus 4 is 8. So the first thing you always check, can you just plug in the number? You're going to learn some cool ways to evaluate limits, but you always check, can you plug it in first? This is going to be 3 times negative 1 squared plus 2 times negative 1 minus 1. So that's going to be 3 minus 2 minus 1, which is just 0. So can you plug in this number? Oh, that's not a highlighter. Can you plug in this number? If so, do it, and then you can get the limit directly. Sometimes you have to do a little bit of algebra first. If you can't plug in 2 into this, because if you do, you get 2 squared minus 4 is indeterminate. So if you plugged it in directly, you get 2 minus 2 over 4 minus 4. 0 over 0 isn't anything that you can evaluate. So what you do instead is you check, can we do some algebra? This is going to be the same as the limit as x goes to 2 of x minus 2 over, oh, it's the difference of squares, so it's x minus 2 times x plus 2. What cancels? You're left with the limit as x goes to 2 of 1 over x plus 2. What we've done there is we filled in the hole. There was a hole on that graph, but now we can plug in 2 and we get 1 over 4. So the limit there is 1 over 4. So the second, besides making a table, the second thing you can do is fun algebra. This one looks like it's not going to be super fun, but it actually cancels really nicely. You can't plug in 4 because you get to divide by 0, but if you multiply this out, you end up with h squared plus 4h plus 4 minus 9h over h minus 4, and there's the limit here too. So what do you end up with? The limit as h goes to 4 of a numerator, which is going to be h squared minus 5h plus 4. That's that numerator simplified over h minus 4. And then guess what you can do? You can simplify by factoring the numerator. That turns into h minus 4 times h minus 1, like this, over h minus 4. And look, the magical things happen. You cancel there. Now you can plug in 4. You get 4 minus 1 is just 3. So algebra is your second tool besides a table. This one you can't plug in 0 because if you do, you get 0 in the denominator. So what do you do here? You add these fractions together right there. You add them together. You need a common denominator. So if you do that, you multiply this one by 3 over 3, and you multiply this one by 3 plus h over 3 plus h, like that. It's multiplying by a form of 1. So what does this become? It becomes 3 minus 3 plus h over 3 times 3 plus h all over h. Looks worse, but it's not. It's actually pretty good. That turns into 3 minus h, so you end up with minus h over 3 times 3 plus h all over h. Dividing by h is the same thing as multiplying by the reciprocal. So that's minus h, 3 times 3 plus h, times 1 over h. Those cancel, and you're left with negative 1 over 3 times 3 plus h. So what was h going to? H is going to 0. So now can you plug in 0? You sure can. So as h goes to 0, you end up with negative 1 over 3 times 3, which is negative 1 over 9. So you factor, you cancel, you add things together, you simplify, and then you can plug it in. At the end of this sheet, there are some limit practices for you. You're welcome to do them on your own. They are optional right here. These are optional.